This video is going to look at the laws of thermodynamics and how they affect systems, particularly ecosystems. There are 4 laws of thermodynamics. For this course you need to know the first 2. The first law of thermodynamics is that energy can neither be created nor destroyed. It can only change forms. Energy comes in multiple forms and can transform from one form to the other. The second law of thermodynamics states that the entropy of a system never decreases, it only ever increases. Energy will move from a more concentrated state to a less concentrated state. So as it transforms, less of it will be available for use. The disorder of the system increases. So let's talk about those 2 laws in a bit more detail. The first law of thermodynamics states that energy can be transformed from one form to another, but not created or completely destroyed. Most energy in an ecosystem comes from the sun. Nuclear fusion happens and light energy is emitted, and this light energy is captured by plants and turned into chemical bond energy when they make glucose. Plants get eaten and respire themselves as well, and eventually respiration reduces everything down, and decomposition reduces everything down to thermal energy, at which point that energy is unavailable for the rest of the ecosystem, as we'll see in the second law of thermodynamics. To turn one form of energy into another form of energy is never 100% efficient. And this wasted energy normally takes the place of thermal energy, and this thermal energy dissipates to the environment and is no longer usable to any part of the system, and it's hard to convert back into a usable form of energy. In a natural ecosystem, you need a constant influx of usable energy because the energy decreases. In this case, the light energy from the sun. Obviously, the sun is not a limitless supply of energy, and at some point the sun will stop sending light energy to Earth, and that would stop the ecosystem, aside from the fact that the Earth would have been destroyed before that. We can use a picture to have a look at how the second law of thermodynamics affects the available energy. So you start with a certain amount of available energy, and as the energy is converted into a different form, some of the energy becomes unavailable and is lost as heat. Any future conversions would further reduce the amount of available energy. Eventually there's no more available energy after a number of conversions. So how do the laws of thermodynamics affect systems? Energy is required to create complex molecules, and a complex molecule is less disordered than a simple molecule, and a simple molecule is less disordered than an atom, and atoms are less disordered than their individual components. So you're working against entropy, and as a result you need an energy input, and as a result energy becomes unavailable to the system. It's lost as thermal heat energy as it's converted. Now matter is recycled in an ecosystem, so you're familiar with the carbon cycle and the nitrogen cycle, and we'll see them in more detail later in this course. But energy moves through an ecosystem in a linear fashion. Energy doesn't cycle. Energy needs a constant input, and that's sort of the main take-home message from this law of thermodynamics piece of